Thank you for joining this presentation. And before I start, I have a question for you. Who's here interested in Windows internals more than penetration testing techniques? System admin. So who is here penetration testers? Good. Good. Okay. So, no one interested in Windows internals. Windows internals. I mean, Gosha, yes. This is. What's your name? Olia. Okay, good. Can we give Olia some, like this one? Okay. I mean, she's the only one. She's interesting. That's good. I have something for her, in the slides. Okay. So, let's start a little bit about me. My name is Haidar. I'm working in Industrial Security Service team. In our team, we analyze systems, so we should have many skills, starting from penetration testing, ending with ICS, network, radio. Mainly, I do Windows researches. Last year, I did a research about collecting Windows information through an RPC interface without authentication. So, and there is a tool that you can use in your engagement as a penetration tester. It's called an RPC. You can check it. You can enumerate domain users without authentication and check if it exists or not. So, what is talk about? Nowadays, in well-monitored environments, it's really hard to get Windows secrets and credentials because it's blocked by almost all EDRs and SOC teams. So today we will see, in a nutshell, we will see simple way how you can bypass all these restrictions. But the main idea from the talk, it's not about the way itself, but it's about to give you the knowledge that you need to develop your own way, or at least understand how these EDRs detect you, and maybe you will also improve some old methods. So to do that, we will start talking about where this credential saved, which is Windows registry. After that, we will talk about the subsystem in Windows that's responsible for managing the secrets. It's called LCA, or Local Security Authority. And third, we will talk about the ways that we can get these credentials, what is the positive, what is the negatives, and what is the techniques under it. And we will talk also about how the EDRs detect this kind of activities, how we can bypass it. In the fourth stage, we will introduce our new way, and in the end, we will see a demo how you can enhance your red teaming techniques. So, starting by Windows registry. I think most of you deal with registry before. What is registry? It's just big database that contain information about configuration for both operating system and applications. And it came to replace an old system called INI files, where the configuration was saved. And it's actually not only saved application and operating system configuration, but it contains many more information like users profiles, system information, application configurations or information, and also Windows secrets for the users and others. And the users that want to access this registry can do it very fast, because as not too many people know, it's during the runtime, it's on the RAM, so you can access it for write and read very fast. And it also packed to files before the reboot. Actually, not before the reboot. We will see now how exactly that's done. But it's back to the files, so you don't lose it after rebooting. So, and this registry used by many Windows subsystems like kernels, SAM, applications, and many more. Now the registry, it's, oh my God, the slide, sorry for that, but it was okay, now it's not okay. So, the architecture of the registry is organized as a tree of keys and values. The key, you can imagine, are the folders that contain another sub-keys or values or folders, and the value you can imagine as a file. And for each value, we have 3 entries named that type and data. All the registry paths start with something we called a root key or predefined key, which start with the word H key, and it's mapped to a handle to the key, and it's actually like the paths of the registry is like the paths for the file system. It's splitted by forwards, backslashes, sorry. And for example, here to the photo to the right, you can see that if I want to access the keyboard key, so the path will be H key current user control set keyboard, and inside keyboard we have 4 values, and for each value name the data and type. So So we have many root keys. We'll concentrate in 3 of them. The first one is called HKLM, or HK local machine, which is actually the main key inside Windows. Under it, you will find the information about hardware info, operating system settings, and most important for us, the user's credentials and the Windows secrets under this key. And this key is represented on the disk by multiple hives. We will know like later what is the hives, which is like we can imagine it now as a files. Under like system root, system32 config, you will find files like software, system, SAM, security, and default. Another key is called HK users, where actually, that's where all the Windows users there will be, and it's separated by their SIDs, and it will contain information about the users, like the environment variable, the desktop, and many more. And there is another key called HK current user, HKCU, and actually it's just like another map point from the HK users that represent the current logged in user to the system. And the information or like the files for this key, you can find it under the user profiles. Actually, the other keys, like maybe will be, you will see, like you will meet another root keys, and actually it's also like just map point from some keys inside HKLM or inside HK users. Now, what is the hives? The hives actually it represent the registry. As Microsoft defined it, a hive is a logical group of registry keys, subkeys, and values. It has its own format, like binary format called regf, and it's loaded to the operating system memory when the operating system started, and it's represented by the kernel by an strat called CM hive, and CM here is like configuration manager hive. And for each hive, there is a role. For example, we have like SAM, where it's related to the SAM database. We'll see it where the Windows credentials there. Security, it's related to the LCA policy database, where the Windows secrets there. System, for example, it contains information about the system. It contains some keys that used for decryption for Windows secrets. And for our friend Olia, where is Olia? So about some Windows internals, like here, for example, I want to talk about the life cycle of the registries. So the registry have, or the hives have multiple types of the files. So it can be on the disk, or it can be on the disk and memory at the same time, and it can be in the memory. So when the operating system starts, the kernel will load these files from the disk to the memory and represented by CMH hive structure. And after that, when the user wants to read some value from the registry, like for example, using some C code or open the regedit.exe and inspecting some value, what's happening under the hood, you don't read like from the files. There is some system call will be happen to the kernel through an API, and after that, the kernel will return the value for you. And for the writing, it's also the same. But in case of the writing, after the kernel write it to the memory, there is some mechanism called the flush mechanism, or lazy flush, sorry, that will write this information to the file to the disk, not lose it after rebooting, and that's done like each couple of seconds. So now here is the photo of from Windows Debugger about the loaded hives in the memory, and we can find under the hive address is actually the address of the struct, and in the end we find the file name, which is related to the hive on the disk that's related to this struct. Now, as you know, everything in Linux is a file. Everything also in Windows is an object, which we called it a kernel object that we cannot access as users. Like from the user mode, we get handles from it, and the subsystems that are responsible for this handles or objects called like object manager. And actually the registry is like not exception, it's also on a kernel object with the type key, and it's represented by a configuration manager in the kernel mode, and also it has in the root of OMNS, which is the object manager name is made, it has a root, and like you can find it as an /registry, which is not directory but it's a key, and inside this key we can find another multiple keys, which is A, for example, subkey, which can be used for when you load in Hive to the memory machine, which is represent actually the HK local machine. So In user space, we have HKLM, but in the kernel, it will be like machine user, which will represent HK users, and WC, it used for Windows container applications. And here, so now, very important thing that now we have two types of paths. Path that's Windows user application and the standard called Win32 path, which start always by root key, like for example, HK local machine. But in the kernel, that's what will be replaced for the registry machine, which is represent HKLM. So the kernel will understand it without this like root key. And after that, actually, the keys is the same structure. Now here, if you want to inspect this namespace, so under the registries, like you can use NT-Object Manager in PowerShell. So you can list the subkeys inside registry, and you will find it a machine user WC as we saw. And here, just one note, like as I said, registry is not a directory; it's a subkey. But inside, like the NT-Object Manager, when it receives LS, will call some Win API or like system calls that will list the subkeys. So here we can find, like if we list the subkeys under registry machine, we will find it exactly the same under HK local machine, and the same for the user. It's exactly under HK users. Now, I want to show you, like, if you have a user code that read some value called product name under like a key, software, Microsoft Windows NT current version, what's happening from your user code till NTDLL, how this translation happened, how we call like the functions inside NTDLL. I will concentrate on obtaining the handle more than obtaining the value, because that's what's interesting for us. Now this is the code. It's simple code. First we open a handle for this kernel object or for this key, and after that we use this handle to read the value. Now here's the registry open key. It's in the photo in the middle. You can see the definition for it. It gets many arguments. The first one will be either the handle of a key that you already obtained before and act as a container for this subkey, or it can be a predefined root key. And in our case, we are using HK local machine, and as you can see in the photo in the bottom, like it's a macro defined and some hex value. And also here's all the root keys and their hex values. And here's something interesting, like how the user mode application will distinguish between a usual handle from the kernel, because it also has like some hex value and these values. And the special with this root key values, it's start like, as you can see, it start off with 8, and so it can be like and the highest bit here is 1, and it's actually the same handles that's used by the kernel, so it can distinguish that it's not like a usual handle for like a key that we already obtained, but it's like predefined root key. So now during runtime, what's happening, the registry open key EX will be called inside the kernel base, and what it did, nothing. It just reset the arguments for another call called registry open key external A. Actually, there the magic happened. Inside it will be 2 calls to the kernel. The first one, it will get a handle of the root key, and the second one, it will use this handle to get handle for the subkey. And in the case of the root key, there is another call will be called in the photo in the bottom. It's called map predefined internal, and it's not documented by it's obvious its work from its name. It will translate this hex value for HKLM to path that understandable by the kernel. So HKLM will be now registry machine, just a string. And after that, we have a call to NT open key, which is inside NTDLL. Also, it's not documented API, but it's very simple. You can find it online. So it's start by the arguments. It's just return the first argument will return handle of the key. The second is their access, and the third it's like very famous struct called object attributes. And for us, it's interesting the two arguments. The first one is the second, which is the root directory, and here it's like, as you see, it's a handle. So it can be handle for the key that you already obtained and act as a container, or it can be null if you are obtaining a handle for the root key, as in our case. And the second one, the third argument is like pointer to Unicode string, which will be like our key that we want to get a handle to. So here's this struct during the runtime for the first call when we are trying to get a handle for the root key. So as you can see, the first 4 bytes will be like the size. The second 4 bytes is the root directory, and in our case, it's all zeros because like we are obtaining to the root. After that, we have a pointer to Unicode string, and for this, it will point to some place where there's the size of the string and the pointer for the actual string, and we can see it's registry machine. So now we're obtaining it like as a kernel like. Now this is the second call when we use the previous handle to get the new handle for our key, and the length, as you can see, is the same, and we have after that the root directory, and inside the root now we will have the handle of the previous from the previous call, and after that we have the string, which will be like our key software Microsoft Windows current version. And after we obtain the handle, there is a call inside the NTDLL will be called. It's called NTQuery value key that gets this handle and the value that we want to read, and it will return the value. So hope it was not too much complicated. So now let's move to the next subsystem. It's called local security authority. What it is, it's from its name. It's responsible for all aspects of local security on the system. It's run under LSASS.exe, and what's, for example, when usage for it, like when you enter your credentials, so it will provide you the login package. In our case, like it will be interactive login, and after that it will validate it. If it's valid, it will generate a token, and it will maintain this token through the session. What it does also, it's ensure to maintain this user credential and ensure it's not exposed by plain text. So even if it's hashes, it's also encrypted inside the registry where it's saved, and also it's stored inside the LSASS memory, the hashes for the users that we already use. And also it's maintained to save it under the SAM and security hives in the registry. This database or this LCA exposed two databases. The first one is called SAM database, which is mapped to the SAM registry hives, and inside it you will find the users groups for both built-in and local domains. Also there is another database called policy database or security database that will be mapped to the security hive. Under it you will find the user privileges, trusted domains, and Windows secrets, what we called LCA secrets. Both databases you can access remotely through two protocols. The first one called MS-SAMR, the second MS-LSAD, which is exposed to RPC interfaces. So you bind these interfaces, start to call function to access the both databases. Also, one note here, like even if you are using some APIs to collect, to interact with these databases locally, so there is no direct APIs to interact with these two databases. So there will be like some IPC magic happen through RPC, and the databases, you can interact with it. So for the SAM database, expose multiple objects. The first one is a server object that represents the whole SAM database. The second one is a domain object, which can be local or built-in. And for each domain, we have it also exposed three object types. The first one is the user that represents the user account. The second one is called alias, and here's the surprise: it's represent the local groups that we know. But there is another object called the group, which is not a usual group that we know. It's just used mainly in Active Directory environments. So here the built-in domain, actually, like I think most of you like familiar with built-in administrators, and when we say built-in administrator, actually the built-in is a domain represented in the SAM. It has its own SID and exposed the group, user, and aliases, and inside aliases we found the administrators. And for the local domain, it's represented by the host name of your machine, and also it's exposed groups, user, and aliases. If you create a group, it will be inside aliases, and the created group users will be inside user. Here is this slide for Olia about the SAM database objects. Like I said, like it's objects, but actually it's not a kernel object. It's the data structure inside LSASS memory. You find it in the photo to the right. It's not documented. For example, the struct like SAMDB object will contain information about specific object determined by its type, and what's happening, this LSASS in this case will interact with the registry to create this kind of structs. And the returned handle, when we say like it's a returned handle to this object, actually it's not like it's not like a kernel handle. Also, it's not like usual RPC handle, it's RPC context handle. And what is the context handle in the RPC is just kind of token that maintain the session between the client and the server. So the server will know like the identity of this client, like what domain is he open, what user he opened before. And Microsoft tell about this context handle. This handle will contain the granted access that you get to this object, the handle type, which will be the object type itself, like this server, domain, user, and it will contain also a reference for the object that inside the LSASS. So the second database is called security database, and it also exposed multiple objects. The first one is the policies that represent the security, that represent the whole policy in the system. Trusted domain. Actually here, like in the old days, the trusted domain was saved here, but now if you upgrade, now after they upgrade to a domain controller on Active Directory, the trusted domain will be saved inside ntds.dit. And you have account, and the account here is like represent the privileges of the accounts. And you have a secrets, or the secret object, which represent the LCA secrets, for example, machine account password, cached credentials for the domain, and DP API keys. Now this is like high view for the security database, exposed 4 objects, and one of them is interesting is account, and inside the account you will find all the accounts that have privileges, and actually like usually it will be like the groups, and inside each group you will find the privileges for these users. Inside this group also you will find the system access, meaning like which allowed, like which kind of login it's allowed, like interactive, network, and etc. So here is, I want to show you in this slide the view about if you execute some Win API, net user enum, it's called like to collect information about the users in the system. To the left you will see the now that's good. To the left you will see the all the APIs that's called, and to the right you will see how many times for just one net user enum. And so in the beginning we'll see like it's SAM connect will be called once, which meaning I'm interacting with an object that's it's just a server. After that we interact with the domain object with SAM open domain. We have 2, and because we have like local and built-in, so we called it 2. And after that, for example, we are interacting with a user's object, so we have SAM open users. It's called 6 times, meaning actually like we have 6 users inside this system. Also here maybe like sound a little bit complicated, but for sometimes you will find some calls like SAMR connect, not SAM connect. And actually there is a difference. SAMR connects, it's interact immediately with the RPC servers inside LSASS, but SAM connect is actually, it's defined in some DLL called samlib.dll that act as a wrapper for the other APIs. It's the magic of IPC will happen inside this DLL. So the user API not care about like binding the RPC interface, taking tracking of the RPC handles. So it just like call it, the SAM connect will be called, and it will do all the magic. So here is the sequence of this API. So we will start with net user it will start with net user enum. After that, it will connect to the server, open the domain, which will be twice here actually, enumerate all the users inside it, open each user, and trying to get information about each user by interacting with these objects that we talked about before. Now about the secrets. Actually, like you found like there is APIs that to interact with SAM, but actually there is no way to get Windows, let's call it credentials through APIs, like through SAMR APIs. So what we do also actually for the LCA is the same. I mean, like there is APIs, but you get it encrypted for this secret. So like in the end, you should interact with the registry. So for the getting user password, interacting with SAM, you should interact with registry. You should interact the same way that we see it in our code. You should open a handle and query a value for the values inside SAM. But there is some special thing about SAM and Security Hive. You couldn't access without system privileges. Even if you are administrator and you want to read these values through these APIs, you cannot access it. There is another way to access it. We'll see it later. But now I just want you to know, like, it has an ACL for system privileges. And here, the registry architecture under the SAM, where the user's password saved. So it's actually inside the account, inside domains, you will find users, and inside users, you will find SID, actually RID for each user. And inside each RID, you will see a value that represents the user hash. But this value is encrypted by a key called boot key that you obtained from a system hive. And actually, for this reason, when you like try to get credentials from the system, you need 3 hives: system, SAM, and security. And for the system, we get only the boot key from there, and we decrypt the other with this boot key. Now about Windows literal movement. Like, you get initial access to a system, and your goal now is like to pivot to other system. How to do that? The easiest way is just to get credentials and reuse these credentials for other system. How we can, like, you can use this even if you decrypt it with a clear text, or you can use path the hash for the Windows user credentials. How we can do that? I divided to 3 categories. The first one, I called it remote collection, and actually it needs non-UAC filtered token. The second one is a local connection when you have, for example, shell to the system, or when you have interactive login. And to read this value, you need either system or non-UAC filtered token. And the third one is about memory collection when you're accessing LSASS. I will not dive inside LSASS now, but I really recommended at like 5, I think, my colleague Gosha will talk about LSASS, how there is a unique way to get credentials from there. So let's start with the remote collection. In the remote collection, I think most of pen testers use like in-packet secret dump, the usual way. And what's happening under the hood inside the in-packet secret dump? So there is an RPC interface that allows you to interact with the protocol called the remote registry protocol. And under it, there is just normal functions that emulate the function under like usual Windows API. And it's allowed, like what's happening in packet first, it will read the boot key from the system using one API. And after that, it will try to read some unsecurity, but because it has some it has ICL and system only can access it, so it will pack it up to the hives to the file using regsave key API, and after that it downloaded through SMB and extracted offline. The downsides, in my opinion, here, like enabling remote registry is not good in the system. It's indicator. Also saving the hives on the disk also is like a big red flag. The second way, it's a new, like I think a year ago. I don't think it's merged to the in-packet or the secret dumps yet. You can find it, of course, in pull requests, and it's called inline mode. And I really recommend to use it. It's what's happening the same. It enables remote registry protocol. After that, it reads the boot key from the system hive. But there is some guys that's found like there is an API called paste reg open key that it can you can give it a SE backup privilege option. And in this case, you can read the values from SAM and security on the fly. You don't need to save it on the disk. And in this way, you bypass something like the ACL. And after that, you extract the secrets. The only downside here, I think it's like enabling remote registry. The third way, it's used inside NetExec. It's really new, like 3 weeks ago they announced about it. It's called NTDS Dump Pro. They introduced it, I think, just to dump NTDS because, like, you know, like it's really hard to dump it. There's no way like to direct interaction with it. So what it did, it executed a PowerShell script that read raw data from the physical disk by getting a handle for the kernel objects that represent this physical disk. And after that, they will parse in specific offset, where is NTDS, where is SAM, where is security, and they will do the decryption offline. And downsides, I think, like executing PowerShell scripts is not a good idea. Also, writing this raw data disk on the disk, raw data and the disk is not a good idea. Now for the local connection. For the local connection, the first method, and also it's used by many of us, like you open the shell or like CMD and type press save, and you save the security, SAM, and system. What's happening under the hood, actually, you pack this file, these hives into the disk by using save key API, and after that you use it for offline interaction. The downsides, writing data on the disk, and there is also this API, save key, it's well monitored by EDRs, and if you try to access sensitive values like or hives like security and SAM, it will catch you. The second way is like to use 132 APIs, like we see in our example, but it needs system, as I said before, because you need to bypass, to bypass the check for the ACL, and after that you read all the values and extract it. But downsides, it needs system, and also this is like really big frag. If you have untrusted process, like with this untrusted process, you are trying to read sensitive values inside system and inside security and SAM, sorry, you will get catched. The last way, also I recommend it if you have a GUI or if you have an RDP session, for example, it's you open regedit.exe and as an administrator, and you export system security and SAM with a text format, and there is like inside the options, it's very easy to find, just export, and you export it as a text. You copy this text to files and you import these files to your VM and you do the extraction there. It's actually like also a year ago, it's discovered by Orange Cyber Defense. Now, how EDRs detect registry activities. The EDRs work with some mechanism, we call it callback routines, and this callback routines is used for tracking system events. And for example, process creation, image loading, or even registry activity. What's happening, the EDR driver will use, in case of the registry, will use CM registry callback EX, which map to configuration manager registry callback EX to register its callback. And after that, in each event happened inside the registry, this callback will be called by the kernel. And so, the driver will receive two things. The first one will receive what we call registry notify class, which will be the type of the event that's happened. Like I'm reading a value, I'm deleting a key, I'm enumerating keys. And the second one is like data that's specifically to this event. Like if you are reading a value, so you will have the key pass and the value and the name of the value and the value itself. But the interesting thing about EDR routines, callback routines inside the registry, that's the registry in an idle system in Windows. It generates, I think, 22,000 operation per minute in an idle system. It's too much. And if they want to monitor all the events, it will hurt the performance. So what EDR do, it has like two layers of filtering. The first layer, it will filter for certain operations, meaning like, for example, they will filter about reading value, writing values, but they don't care if you enumerate subkeys, for example. The second level, they also will filtering about sensitive, if you access sensitive values or sensitive keys. So like if you read the product name, it's not a problem. But if you read the user hashes, it's a problem. So they use this kind of filtering. How we can bypass the ways that I found to bypass this registry operation. There is two ways. The first one is exploit blind spots. What that's meaning? Meaning it's you exploit the filtering levels. Like for example, if the EDR monitor events under HKLM, maybe you can access this value that you want to read or to write from other hives, because I said in the beginning, like there is too many mount points to access the hive. It's like the data under the hive itself. And or maybe you can find some uncommon API is that's not registered inside the driver, like for reading or writing data. Another way that I found also, it's for attacking the callback routines itself. So inside the memory, they will know where the offset of this callback, and they will patch it so this callback it will never be called by the kernel, or the driver will not receive it. Now to our silent harvester. What I wanted at that time, I want some tool that using in our engagement that don't write data on the disk, don't enable remote registry, don't rely on the system. Just I'm a local administrator and I want to read the values on the fly. How I can do it? At that time, I couldn't find a way, but while I'm reading a book for James for Show, it's called Windows Security Internals, I really recommend it. And inside it, he was using his module NT-Object Manager to read values from the SAM and the security on the fly as an administrator. And when I check, it's open source, and I found he using NT-OpenKey-EX native API. We talk actually, like before, like in the bottom, we talk about NT-OpenKey. It's exactly the same, but with open options. And the magic under the open options. Actually, he just specify a backup restore to the each call where he wants to get the handle of the key. So in this case, like telling the kernel, okay, I'm opening the key for backup, not for read. So in this case, he bypassed the ACL after, of course, he enabled SE backup privilege. And at that time, I was able to read all the values on the fly as a local administrator. But after that, I face a problem. And actually, it's obvious. I use untrusted process, like very small exe, that try to access sensitive value, and I get catched by all the ADRs. So now I want to bypass it. I don't have too much experience in bypassing ADRs, the techniques itself, but I want some simple way, and in the same time it's simple and it works with almost all ADRs. So remember, like we said about attacking blind spots. So I think maybe I can find some API that it's not used too much and it can be used for reading the registry values. So I found actually an API called registry query multiple value. So instead of like getting a value in this one, you can get multiple values. And I use it to read the values that I want, and I get surprised that it also like bypass almost all the ADRs that I test, and I test with very, very strong and famous ADRs just like this. So now in our code will be by first enabling SE backup privilege, after that using NT-OpenKey-EX with backup restore to bypass the ACL. After that, we will use uncommon API like registry query multiple values to bypass ADRs and do the decryption on the disk on the fly, and after that print it the results. So now how we can use it to enhance our engagements. Again, the current downsides that I found in the tools, that's enabling remote registry, saving data on the disk, accessing sensitive value with untrusted processes, and also enabling system. So, for example, this is the first one with the remote collection. How we can do it? If we have like execution method like WMI, DCOM, SMB exec, and we can upload our executable, and after that run this executable and get the secrets on the screen. Or like if we have interactive login like RDP, we can copy it to the target machine and run it. And here is a small demo how I do it. And now I have like ADR on the Windows machine, and I'm using secret dump. So here, as you can see, I get access denied because it's the ADR catched me. It detects that I'm writing data on the disk in a specific place. And now I want to show you the size of this executable. It's just 152. And now I upload it through SMB client to the temp directory under the C. Like I'm fast in typing, but this recorder was crazy, like inside Kali. Now clear. Okay, now I used I just used DCOM exec with MMC 20 object. And now I just will navigate to the temp and run the executable. Come on, okay.
Sometimes it feels like there are hours in a day to get work done. So when more hours is getting
And here, like, we have the hashes, user hashes, and LCA secrets. So, in the conclusion, always start with simple methods. As you can see, like, it was not like rocket science. Also less common APIs, you should use it to read sensitive values. If you face some problem, also try to run this executable. If you found some trusted process, like for example python.exe, if you found it in the target system, try to read it. And for the blue teamers, like, always consider monitoring like less common APIs for getting the information. And really want like to map to the references. Like, there is a lot of great books here, and Google Project Zero have a great series about registry, like 6 parts, and also like 2 books. One is called Windows Security Internals for James Forshaw, and the other is about evading EDR by Matt Hand, also recommended. And thank you for listening.
All right. Thanks, Хайдар. Так, вопросы можно задавать на русском и на английском.
Да, можно.
Прошу, да, в первом ряду.
Hello, Haidar. Thank you for your presentation. It was really great. I have some lemma questions. Am I right that for use the silent harvester, the least privilege that you need to obtain is backup, SE backup privilege?
Look, yes, and usually this privilege is under like local administrator. If you have a local administrator, you will have this SE backup privilege. Yeah.
So, and the key of your technique is the using the undocumented API function?
No, look, I mean, the key here, like first, to bypass the ACL is using undocumented function, like NT-register open key EX with this undocumented option. But I mean, this is a way to bypass the system privilege, but to bypass the ADR is just using unusual APIs for reading registry values. Yeah.
Oh, okay. Thank you.
You are welcome.
Hey, thank you so much for the presentation. I just want to mention one technique which you didn't mention, which is very famous. So in case if you're on host with a local privilege, like local admin privilege, when you're dumping the registry hive like directly like from some registry hive or from security, it's not a great idea. But in case if you just copy that registry hive under the different name, then EDR does not detect that. I just saw that on the previous engagement there was Sentinel-1 and it didn't detect when I just copied that stuff. But in general, I don't have any challenges for dumping some hashes. My real question is how good is to dump the LSASS memory in 2025.
Look, the first thing, you cannot copy it. I don't know if I get your comment correct, but you cannot copy the SAM and security from the
system.
Yeah, from the live system you can't. You have ACL, you have a system, you can't. Yeah, there is a way. You can, if you have like interactive login, you are sitting in front of the laptop, there is no BitLocker, so you can reboot from Kali and from there, or like any Linux, and from there you can mount this driver and get the data. But like if you have in live systems, that's impossible. You cannot copy it. Right, so this is the first comment. The second one about LSASS, actually, it's hard. It's really hard nowadays with even with Defender. Like just like it's really hard. But as I said, I really recommend like Gosha talk. Will be at 5. He will talk about a new novel way to dump LSASS process, and I tried it with some engagement, and it's really good. Also, one comment here about if you face problems with dumping hashes, it's depend on the environment, depend on the how your customer is working, is depend about the access that you have to the system itself. So thank you for the question.
You know what? Just one comment.
Yeah.
In case if you just copy the registry Hive Hacky, local machine, right, and just navigate to the security, you can just easily copy even on the live machine into the different registry Hive. I know that you cannot just access on the file system, but in case if you just copy the registry Hive, it works.
Yeah, look, there is no copy. There is export. Like I mentioned it, you can export it as a data, as a text. You copy this text and put it. But even if you open it, there is no option like a copy, right? There is no option like a copy.
Just come in 1 minute to me. I can just navigate and check.
Okay, yeah. Thank you.
Thank you so much.
Thank you.
Так, есть еще вопросы? Так, в конце.
Hi, thank you. I wanted to ask, what's the most underlooked or overlooked Windows silent executions happened in your history?
What do you mean by? I mean, by the ways of extracting the secrets.
Yes.
I recommended 2 of them. Look, this inline in packet secret dump is really a good way to do it. Yeah, and for interactive, I really recommended using this export as a text and copy it in the VM and extract it.
Text to VM and
extract it. Yeah,
extract
it's just it's a new way by Orange Cyber Defense. You can find it actually online, and the presentation will be also available online, so you can check the ways and check it.
Okay, thank you.
You are welcome. Any other questions?
Еще вопросы, да.
По-русски можно, да. I'm learning.
Спойлер, спикер все это время говорил по-русски.
It's hard language, but I'm learning.
Так, вопросы. Раз. Мы за них вознаграждаем. Ну, не мы, а Сюмберч. Точно не хотите? Там футболка? Нет? Раз. Так, пожалуйста, в первом ряду.
А ссылка будет, господин.
Это вопрос, да, будет.
Еще, может? Ага.
I have a little out of scope question. So, have you tried to do something that John Hammond did back in the days when he invoked a request from the, I believe it was a system authority or something like that. It's the only source that is available during the Windows installation, and it is like the real root of the Windows.
No, actually, and I didn't get your question exactly. What is the goal in the end?
What do you mean?
I mean, you obtain some system.
So basically, in Windows, there is how can I say it? There is some places that you are unable to edit even with a administrator privilege.
Yeah.
And if you, for example, mess with installer of some kind, it can really break your system because you cannot delete it afterwards with any privilege except of the installation privilege.
I knew it, but I didn't do anything related to it. Sorry.
Oh, right. Thank you anyway.
Welcome.
Еще вопросы? Еще претенденты на мерч будут? Нет? Раз, два, три. Ну что ж, тогда поблагодарим Хайдара.
Спасибо.